Okay, so today we're going to go over glycolysis, which is the first step of cellular respiration. So glycolysis breaks down a 6-carbon glucose molecule into pyruvate, which is a 3-carbon molecule, and in the process we produce 2 molecules of ATP. So glycolysis takes place in the cytosol, and it does not need oxygen to occur, so it can occur under both aerobic and anaerobic conditions. So we first start with our 6-carbon glucose molecule, and this is the energy investment phase. So we have to add ATP to break down our molecule into the 2 3-carbon molecules. So first, hexokinase uses ATP to add a phosphate group to our molecule, making this glucose 6-phosphate. So when we add a phosphate group, because it's a negative charge, this makes the molecule more unstable, and we need our molecule to be unstable because we want to break it down. So then phosphoglucose isomerase basically just rearranges the molecule into a more favorable form. And then we have phosphofructose kinase. So this again uses ATP to add another phosphate group. Now that we have 2 negatively charged phosphate groups in close proximity, this is really unstable. So this molecule is going to break down. So fructose bisphosphate aldose splits our 6-carbon molecule into 2 3-carbon molecules. So we have dihydroxyacetone phosphate and glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate is the preferred 3-carbon molecule. So triose phosphate isomerase basically just rearranges it into 2 molecules of glyceraldehyde 3-phosphate. So as we enter the energy investment phase, it's important to remember that we have 2 molecules of glyceraldehyde 3-phosphate. So steps 6 through 10 are going to occur twice. So once we have glyceraldehyde 3-phosphate, glyceraldehyde 3-phosphate dehydrogenase is the enzyme that's going to reduce NAD plus to NADH and add another phosphate group. So here, reduction is an addition of electrons. So we have NADH, and we're adding another phosphate group. So again, this 3-carbon molecule, 1,3-bisphosphoglycerate, is unstable because it has 2 phosphate groups attached. So now we've officially entered the energy investment phase, which means we're making molecules of ATP. So phosphoglycerate kinase, this enzyme removes a phosphate group to make ATP. So anytime you hear kinase, that means phosphate is being removed. So here we've turned our ADP into ATP, and we've created our first molecule of ATP. Okay, so then we have 3-phosphoglycerate, only 1 phosphate group, and phosphoglycerate mutase is the enzyme that's just going to rearrange this molecule, so it becomes 2-phosphoglycerate. Then we have enolase, and enolase is going to remove a molecule of water to essentially create this carbon double bond. And double bonds are less stable than single bonds because they're shorter. So now we have a double bond and a phosphate group in close proximity. So phosphoenolpyruvate is a molecule that's pretty unstable. And when we have pyruvate kinase come in to remove this phosphate group, it's going to make another molecule of ATP and then create our 3-carbon pyruvate. So it's important to remember that this step in glycolysis is not reversible. Once you get to this point and pyruvate kinase comes in, this step is always going to happen. So again, we end up with 2 molecules of pyruvate because steps 6 through 10 occur twice, which means in the energy investment phase, we've created 4 molecules of ATP, but because we had to use 2 in the first phase, that means we end up with a subtotal of 2 molecules of ATP, and we also create NADH. So 2 molecules of NADH, and that's glycolysis, and then it can proceed through the rest of cellular respiration.